All right, everybody, welcome back today. Whew, gotta take a breath on this one because it is our interim. And if you've seen our interim is basically our state exam, right? So it's the culmination of all the other tests that I've done already, or that we've done hopefully together. So notice I got one, two, three, four, keep going, more and more and more and more and more. 34 questions. That sounds about right. And just as you would normally have, you have like a part one section with no calculator, part two with calculator, and the same thing right here. Okay. Now, before I begin, just a FYI, right? This is a long one. All right, we just gotta stay strong. Okay, have that endurance to finish strong with this one. It's a good culmination to study. Okay, especially right before the exam. Especially because this has a lot of the same questions that are copy pasted from all the other right IEBs. So stay with me, all right? Just move along with me, and then let's just get this done. Honestly, let's go. All right. Which number is the closest approximation to square root of 65? So remember, the strategy is square root of 64 equals 8, so a perfect square. Then after 8 is 9, which was square root of 81. So square root of 65 happens to be right there. So square root of 65 should be 8 point something. And in this case, it's closer to 8. Okay. Line Q has a slope of 5 over 2. It passes through the point 0, 0. Follow the steps below to graph the line. So start at 0, 0. And then it says move 6 units to the right. So the question is, according to step 2, how many units up? So in other words, how much are you going to go that way? So they gave us a hint. The slope is 2 and 5, or 5 over 2, right? Your rise or run. So in this case, you're going to notice, hey, look, if I do this one right here, every 2 I move, I go up 5. So I went another 2, I went up 5. I went another 2, and I go up 5 more. So a total of 1, 2, 3 5s, which ends up being 15. Okay. All right, choose the range that contains the value of that. Okay, another radical problem. So if I add everything on the inside, I'm going to get radical. Let's see, that gives me 15. 15 plus 25 equals 40. So square root of 40. Well, square root of 36 is 6. Square root of 49 is 7. So where's square root of 40 going to be? It's in between 6 and 7. And there's only one option. And in this case, it happens to be C. Okay? And if I'm looking at this, 30, 40, yeah. Actually, it is between 6 and 7, but these should be smaller. Okay? On yours, it'll make a lot more sense because square root of 40 is actually over what? So 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. Move this. 47. Where are we at? 47, 48, and 49. So if 40 is right here, what is that? From here, it's 13. So this one is 1, 2, 3, 4 away. So that's less than half. So that should have been like 6.3, 6.2. Okay. Actually, the better answer would have been this one. Okay. So I probably wrote it wrong. But anyways, right, just a heads up. It should be between 6 and 7. All right. That's the key thing. There's a third version, so I probably just wrote that one wrong or forgot to switch it. Anyways, moving on. Okay, look at the line below. Enter the equation, so they told us how to write it. And remember, my favorite equation of all time is y equals mx plus b, because that is what you learned in 8th grade. Because in 7th grade, it was basically this right here, which was proportional. And then 8th grade, you learned, I'm going to move it up and down on the y-axis. That's your b. So how does this help us right here? Well, our b is at 0. Okay, so there's no plus b, right? It's plus 0. I don't have to write that. So all we really need is the m. So how do I find the slope? Well, let's look at it. We're going to take our lattice points, that one, and that one. We're going to find the slope from the two closest ones. And I got 1 and 3. And then m is rise over run, which is the vertical line over the horizontal line. So I went up 1 and I ran 3. So y equals 1/3 x. All right. So what's the closest approximation to square root of 8 plus square root of 18? Ooh, pues, okay. So let's see. I got square root of 9. Now I got square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4. And square root of 25 equals 5. So if I'm looking at this, square root of 8 is somewhere right here. So square root of 8 is like 2.7-ish. Okay, 2.7, 2.8. And then square root of 18 is right after that one. So if I look at that one, it's around 4.2 or 3, something like that. So what do we got? 2.7 plus 4.2. So 2.7, 4.2. If I add those, I get 9, 6.9. So it looks like 7 is my closest number. Okay. All right. Number 6. Choose the equation represented by the linear function. Again, my favorite equation, y equals mx plus b. So let's start with b. My b, where did I cross? It crossed at 2, so it's not 3. And notice it's one of those, 3 now. And I am going down. So it has to be a negative, and those are all negatives. So let's find our slope by finding our lattice points. So I went to the right 1, and I went down 3. So remember, rise over run. So negative 3 over 1. So in this case, it's just negative 3 for my m. So it should have been b. All right, number 7. The scatter plot below shows the relationship between the weeks enrolled in a typing class and the number of words you can type per minute. So notice, if I want to read this graph, the more weeks you spend in class, the more words you should be able to type per minute. Does that make sense? I hope so, right? That just means you're doing your actual work. So, all right. The y-intercept of the predicted line of best fit is at 0b. Here's your y-intercept. Boom, right there. Enter the approximate value. Oh, that was 15. That was easy. Then the slope. What is it? So your slope of the line, it looks like I have lattice points right there, right there, right there, right there. I'm going to pick the closest one. And now you got to be careful, because what we're going to do is we're going to count squares. You're going to say, oh, look, it's going to be 2 and 1, right? You saw 2 squares and 1, but you got to look at your scale. Okay, what am I talking about? I'm actually going from 4 to 6. So that's actually 2. That's the distance. And then I'm going from 35 to 45. So that's actually 10. So my m, which is rise over run, is actually 10 over 2, which equals 5. So my slope is 5. So if I were to write an equation, just because I feel like it, y equals m, which is 5x, plus 15. And it didn't tell me to write it, but it's just good practice, because eventually they'll tell us to write one, okay? All right, Liam claims that the equation y equals 3 plus 4x squared is not a linear. Which statement supports? That means that Liam is correct. Okay, so it is not a line, basically. And when it says linear, it means straight line. Okay? And what do I know about a straight line? Y equals mx plus b. So what's the biggest difference? Yeah, that mx, that x has a power of 1. So let's see, the coefficient is positive. Yeah, that doesn't mean anything. The coefficient, what it's talking about, is the letter that's stuck to your, the number stuck to your letter. That doesn't matter. The function is not a straight line. Duh. Okay, it's not. The function doesn't have a y-intercept of 0, 3. Well, that doesn't matter. The function is a parabola. Yes. So remember, parabola is y equals x squared. So that's where it looks something like this. Remember? Should have touched on it just a little bit. But you should know, n to the power 2, that's a parabola. Okay? All right, number 9. Look at the figure below. Triangle mu is rotated in the reflected form mu prime. Read the statement below. Each row and determine if it's true or false. So W has the same measurement, angle W, as angle M prime. ME is the same length as MW. They're all different letters. Why would they do that? Let's look at the original. Okay, let's see what they tried to do here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, look. It's a right triangle. Okay, so I know that. And both of its sides are 6s, which makes it an isosceles, which means this side and this side is the same. So if those lines are the same, that means that this angle has to be 45 degrees, and that angle has to be 45 degrees. And why? Because a triangle has interior angles that add up to 180. So if one of my angles is 90, 180 minus 90 equals 90. That means that's the other two angles. And if the other two angles are the same size, you cut it in half, and that's how you get a 45. So by the way, that's a special triangle. Okay, you will pick up in geometry. All right. So now let's go ahead and read this. So in this case, it was rotated and reflected, so it's the same size. Okay. So W and M, are they the same angle? Yes. Okay, they're the same. They're both 45. Doesn't matter the original and the new one. Okay, they're the same. So ME. So where is ME? ME was 6. MW is the same. No, that is false. And why do I know that it's false? Because your hypotenuse is the longest side. So it has to be longer than 6. Okay, so they're not the same. All right, and then the last one, MW. So MW, so that's my original one right here. And EW is longer. Okay, I got to read it again. MW is longer, so it's bigger than EW. Yes, that's true. Okay. Again, the hypotenuse. I just said it's the longest side. All right, moving on. All right, straight up equation. So let's go ahead and solve those. There's my wall. So let's combine like terms. So let's identify what we have. I have x's, 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 and x's, units, and units. So what do I like to do this? Because then I can combine like terms. So on the left side, I can't go across yet. Okay. So on the left side, I got x's with x's. So 3 minus 2 is x. And I have a positive 5 units. There's my equal sign. On the right side, what do I have? I have 4 plus 1x, which is 5x. And I have a minus 7. So now I can move things around. So I got to move my letters to one side, aka my variables, and my numbers to the other, aka my units. So let's just move the x's to the left. So let's subtract 5x so that these go away. Whatever I do to one side, I do to the other. So 1 minus 5 gives me negative 4x. Then I have plus 5 equals negative 7. Now what do? I got to subtract the 5, subtract the 5. These go away. And I have negative 4x equals negative 12. And what's my last step? My last step is to divide by negative 4, divide by negative 4, and I got x equals 3. Is that all I wanted? Enter the value of x. Yes, x equals 3. All right, number 11. This is shown in the graph below. It says that the equation of the line is y equals negative 1/3 x plus 3. Why is this wrong? Which is the correct equation? So notice, there's that one, there's that one. So they literally gave me all the equations. So all the reasons, I don't even care, which is kind of nice because I can answer this two ways, right? I can either understand what she did wrong, or I can just write the equation myself and just pick the equation that I picked or that I wrote, and then I'll understand what she did wrong, which is what I'm going to do, right? I always say, just do the problem yourself, especially if you know they're wrong. So let's see, my equation of all-time favorite one, mx plus b. Where do I find my b? My b is right there. So there it is, b equals 1. My y stayed the same. I got to change my m. So my m is going to be my lattice points where I do my rise over run triangle. So I got 1 and 3. So 1/3 x plus 1. So that should be my equation. It is not this one. It is not negative 3x. It is that one. So what did she do wrong? It says the slope should be positive, and notice she did a negative slope. So yeah, okay, that's what she did wrong. But notice I only cared about the equation. That's what's nice, right? And sometimes you get this when you play a teacher and they're like, where did the student go wrong? And you just solve it yourself, and then they'll be like, oh, the answer should have been, and then all I care about is what the answer is, okay? All right, moving on, system. So here it is, right? Those are your options. There's your x and y. So there's either no solution or infinite solutions. And remember, for these two, there's no variables. Okay, that means they're gone, the x and the y's. For the other one, there's one solution. Okay, so let's do this. What can we do? In this case, I'm going to multiply the bottom times a 5. So why did I do this? Because we're going to use elimination here. So the top, nothing happened. I got 2x plus 5y equals 16. But the bottom, I'm going to distribute that 5 to every single term on both sides. So I got 5 times 3x, which is 15x. 5 times negative 1 is negative 5y. And 7 times 5 is 35. So why did I do this? Because when I add these, I can see that, hey, 5 minus 5 is 0. So what did I get left with? I only have 17x equals, and now I'm going to bust out my calculator just to make sure, okay, because mental math is great, but I always want to double check it with the calculator, especially if I can use it. So 16 plus 35 is 51. So what's my last step? Divide by 17, divide by 17. X equals probably 3. So 51 divided by 17, and x equals 3. Is that one of my options? Yes, there it is. So do I even have to plug it in to check the y? I do not, okay? If the other one said 3, 0, then I would have to check. But in this case, I'm done, okay? The answer is D. All right, moving on. So the scatter plot below shows the relationship. Hey, this is the one I just did earlier. Interesting that they asked me this question twice. Excuse me, I'm gonna take a sip of water there. On the interim, right? Like I wouldn't expect them to repeat the questions. So it might be understandable that this is probably going to be on the test, right? That's kind of like my hint, right? Like if they ask me the same question multiple times or a bunch of times, it's probably because they're going to put it on there. Okay, so let's see. The scatter plot. So it's the same thing. The y-intercept, I care about B. Put it in the first box. Okay, no problem. So there it is. There's your B. Where is it? Let's check. I am going by 15s every 2. So 15 divided by 2 is 7.5. So every line is 7.5. So that's 67 point. Ew, that's gross. So let me make that smaller. 67.5. So that should be my y-intercept, not B. Pues 0.5. What about my slope? So my slope, remember, rise over run. So I'm going to pick my lattice points. So there's a lattice point, there's a lattice point, there's a lattice point. And if you don't know what I'm talking about, it's all of these. I call them like the perfect crosshairs, right? So where they intersected, those are all lattice points. Because then we can count easily. I'm going to go over 1, and I'm going to go down 2. But this is where we got to be careful. Even though I said 1 and 2 boxes, what's the value? So I actually went from 2 to 3, so that's 1. And I actually went from 37.5 all the way down to, yeah, that's gross. So let's get this back up here. So we said each one was 7.5, right? So what's 15 plus 7.5? That's 22.5. Wait, I don't even care because it's 2 boxes. 2 boxes from here to here is 15. Okay, that's easy. I was going to start subtracting. I didn't have to. Probably some of you guys already did that in your head, huh? Okay, so then what is it? It is 15 over 1, which is just 15. So if I write the equation of a line, y equals 15x plus 67.5. Oh, and this is why I like doing this. Why is this wrong? I am going down. So that is a negative 15. So let's put a negative there. And if I do negative, now I know my equation is going down because my line is going down. Okay. All right. Moving on. So look at the right triangle, enter the value, and anytime I see right triangle, I am thinking a squared plus b squared equals c squared. There's my a, there's my b, there's my c. So 10 squared plus 17 squared equals x squared. So 10 squared plus 17 squared, and that equals 389 equals x squared. How do I get rid of the square? I take the square root. So then I get x by itself. Let's do it to both sides to be fair. So square root of 389 is roughly 19.723082, blah, blah, blah. Round to the nearest hundredth. So if I round to the nearest hundredth, that's 2 decimal places, so I care about the third. So my number is going to stay at 19.72. And that's it. We're done. And just to make sure, yes, this one is the longer side, so it's 19. I think I'm okay. All right, moving on. Rectangles. So now we got geometry up in here. Rectangle A went through a single transformation to create rectangle B. Okay, you only did one thing. You moved it, rotated it, flipped it. Okay, only once. Kendra says the single transformation must have been a translation of 7 units to the right. So let's see if I translated the bottom right. Oh, this one should have been to the left, right? To the left. So I'm going to start here. So 1, 2, 3, 4, 5, 6, 7 to the left. Yes, it's 7 to the left. Choose a different transformation that could prove Kendra wrong. So if you rotate it counterclockwise, will that work? Well, let's think about it. I'm going to go from A, and if I rotate it counterclockwise, oh, so I like this one better. So if I rotate it counterclockwise, boom, does that look like B? No, it went vertical. So it can't be rotation. Oh, pues. Can you mirror it across the y-axis? So if I mirror it across the y-axis, there's my mirror. But this is only 1, and this is 1, 2, 3. So that is not the same distance. Mirror across x equals -1. So that's over here. So now that's 1, 2, 1, 2. So that one looks like it will work out. And I already said rotation 90 degrees will not work. Okay. All right. Choose all the transformation combinations that will always create a congruent, that means it's exactly the same, figure to the original. So translation followed by dilation, no. Translation, rotation, yes. Reflection, rotation, yes. Translation, rotation, yes. Dilation, no. So which ones am I Xing out? Dilations. Remember, what you want is rigid transformation. That's your translate, rotate, and reflect. that keeps this triangle exactly the same, okay? Whereas if you dilate, you went from this triangle to a bigger triangle or smaller triangle. You see that it gets bigger or smaller. So that does not work. Okay? All right. So which of the following tables belongs to 4x plus 5, y equals 4 plus 5? Okay, so a couple things to remember for this. Again, my favorite equation, mx plus b. Essentially, your rule is you're going to multiply the x times 4, then you're going to add 5, and it's going to equal y. So here's what I'm talking about. X times 4, what is that? 4 plus 5 equals 9. It is not 2. That's all it is. That's all it's saying. That's the rule, right? I just moved that y to the other side, okay, to make it easier. So that's one way to do it. The other way to do it is understand that your b is when x equals 0, since it's your y-intercept. So here's what I'm talking about, right? Enter your b. Look at what x is. X is 0. So when x equals 0, b equals 5. There's x equals 0. This one is not 5, so it can't be that one. 0 and 5, it could be that one. And then 0 and 17, it can't be that one. So my only answer is C. Now you think about it, it could have been A, but if I don't use this method, and if I go backwards, notice I'm going, oh, minus 2, minus 2, minus 2. So this one is minus 2, minus 2, minus 2. Well, what happens if I subtract 1? So if I subtract 1, that's half. So if I subtract 1, that's going to be 1, and x equals 0. So when I get 0, I get 1. It is not 5. So that wouldn't have worked out. So it's your preference. I personally like this one because all I got to do is find x equals 0. And usually they'll give me a table with that. But if that doesn't work for you, then this rule right here is really nice as well. Okay. All right. Moving on. So let's look. Oh, I remember this one. This one, you just have to go ahead and figure out which ones belong together. So corresponding sides. So BAL somehow went to that one. So let's find our corresponding sides. Well, I know that this side is flat. Actually, let me use this. This side is flat. So that one goes with that. The tricky one is AB or AL. So AL, if you notice, it's a very skinny right triangle. Remember if you did the other videos? So if you can't see what I'm talking about, to get AL, I did this. It's kind of like our slope triangles, right? So if you look at it, AL kind of looks the same as Y. So AL goes with Y, which means that T goes with AB. All right, so now it's just matching. So AB was green, that goes with T. BL is red, that goes with O. And LA was purple, which goes with Y. Okay, next one. The Summer Carnival is coming up, and they have 2 promotions going on. Pay $49 up front. And again, my favorite equation, right? Write a system of 2 equations. Y equals mx plus b. The thing that makes it easier, m is your rate. When you see the word rate, you're looking at the words per, every, hour, an hour, a hour, per minute, per shirt, per video game, per hot dog, per ride, okay? So it's really nice because it tells me exactly how to write it. I'm going to have y, it equals $49 plus $7 per visit. So see how my v is going to be instead of my x, right? So if I said $2 per hot dog, I say 2h. $50 per video game, 50 per video game, or v again. $20 per shirt, 20S. You get the pattern? Okay. So it makes it really nice with the word problems. So what about the next one? I got y equals 64 and then $8 per visit. So that's 8V. So there's my system of two equations where they model. So the money they spent is y. The number of visits, instead of v, they want x. So that's how I switch it. Enter option 1's equation in the first box and enter 2 in the second. Okay, so now I'm just going to revert it. So y equals 49 plus 7x. And for my second one, y equals 64 plus 8x. Okay, so this one's a little weird because they told me to use x and y, which is fine because, again, I am used to doing this. And notice I could have switched these back and forth because 3 plus 2 is the same as 2 plus 3. You'll get it right either way, okay? The only thing that's weird, like I say, sometimes they'll actually tell you use V and then use T for the total, right? Because that's like your money. Or use M for money, okay? You know, you got to think of the letters, all right? But it tells you which ones to use, right? Money is Y. And if that means V is X. Okay, you just switch them with what it tells you. It's really nice. All right. Okay. Mr. Bertrand and his wife are on another long, or I should say beautiful. I only saw the word long because, oh, yeah. Hike. Yay. Okay, Mr. Bertrand was constantly checking his watch for the time and jotted down the time and how far they had constantly traveled for 2 times. Okay. So we're walking should I have said consistently? No, constant, right? That means we're going at the same pace, basically. All right. All right, determine the time in hours that it would take Mr. Brother and his wife to finish 45.6 kilometer hike. Oh my God, that's so long. That's ridiculous. Yeah, this is a word problem, okay? There's no way I'd walk that far, okay? It has to be under 10K. I'm going to tell you right now. Okay, I think you pass 10K, I don't bother. I wait in the car and watch cartoons. Okay, I tell her I ain't gonna go. Anyways, how do I find this? Okay, so I need to figure out 45.6, right? So what is that? So if it's constant, all I gotta figure out is how did I get to 15.2 after 4 hours? So all I gotta do is divide. So bust out my calculator right here. And then 15.2 divided by 4, and I got 3.8. So that means 4 times 3.8 is 15.2. Let me double check. 4 times 15.8. No, 15.8, that's way off. Okay, 3.8, sorry. It's 15.2, which means if I put 7 times 3.8, that gives me 26.6. Yes, it does. So that means if I want to go backwards instead of multiplication, I'm going to use division. So now I'm going to say 45.6 divided by 3.8, and that equals 12. So it'll take us 12 hours to finish that. Okay. Yeah, that's a whole day. Okay, I don't want to go on vacation and spend 12 hours walking just to go see a waterfall. Okay, gross. All right, ugh. I'd rather go eat a burger. Okay, or something good, local delicacy. Anyways, moving on. Oh wait, I'm not even done. Okay, Mr. Bertrand and his wife reached a beautiful lake. It was beautiful. I'll give her that. Okay, after 11 hours. Enter how far they had traveled. Okay, so now it's the same thing, right? So now instead of 12 in my little table, it's 11. So how far did I get there? So what did I do if I want to go left to right? I multiply times 3.8. So 11 times 3.8, it was 41.8. All right. 4.8, no, 41. You know, I already wrote it wrong. 41.8. So 41.8 kilometers to see a beautiful lake. I mean, it had glaciers and stuff, and it was cold, but was it worth it? Nah, not really. Okay, but it was beautiful. Anyways, moving on. Enter the value of x. Okay, let's just solve an equation. I can do that. So luckily, there's nothing to do on the right side till like the end, it feels like. So I'm going to focus on the left side. And first thing I tell my kids, got to get rid of parentheses. Parentheses means multiply, so I'm going to multiply to everything inside. So I got 3x plus 1/2 times 4. Luckily, I got a calculator. 1/2 times 4. That gives me 2x. Press delete. 1/2 times -8 is -4. That made it easy, right? And I got equals 10. Now I can combine like terms, so x's with x's, units and units. But remember, I can't do it across. I have to stay on the left side. So the left side, I got 3 and 2. That gives me 5x, and there's a -4 there. And on the right side, I can't combine anything because all I got is a 10. So I'm down to a two-step equation. Why do I say that? Because how do I get x by itself? I'm going to add 4 to both sides so that these go away. And I got 5x equals 14. And then my last step is to divide by 5, divide by 5. And I got x equals 14 over 5. Now if I put that in my calculator, 14 divided by 5, I got 2.8. So either one of these answers is correct. A lot of you guys are going to get 2.8, and that is totally correct. If you got 14 over 5, that is also correct. Okay, it's equivalent. It's the same. All right, I got another system. So let's see. I notice this is a second one, so I'm guessing they're probably going to give you one of these for sure. Okay, I have a strong feeling. There's exactly one solution, or there's no or infinite. This one, they set it up differently. Okay, so you could set it up, and if you haven't realized this, there's two equations, right? It's ax plus by equals c, which looks like this, or y equals mx plus b, which is this one. When they do it this way, you can rearrange it so that they both look like y equals mx plus b, or they both look like ax plus by. So if you don't know what I'm talking about, I can simply just add the 3x and add the 3x, and you see how I get, what do I get? 3x plus y equals 9. And on top, I get 3x plus y equals -9. See? Not a big deal, right? Now what that means is that I can add or subtract them, but wait a minute, if I add those, I don't have any letters that cancel. So I want to get rid of one of my letters, right? That's the purpose of multiplying by a -1, so that when I do that, excuse me. All right, so when I do that, what's going to happen? Do I have room? Yes, I do. I'm going to have -1 times 3 is -3x. -1 times y is -y. -1 times positive 9 is -9. On the top, nothing changed, so 3x plus y equals -9. But here's what happened. 3x minus 3x, that's 0x. Y minus y is 0y equals -18. So no x's, no y's, 0 equals -18. That is false. So because there's no letter, there can't be a solution. And because it's false, there is no solution. The other way around it, and let's see if you kind of get this, is you would have seen, hey, look, the y's by itself, the y's by itself. So if I move that 3x to the right side, I'm going to get y equals -3x minus 9. The second one, y equals -3x plus 9. Can you look at these two lines? If I were to graph them, one starts at -9 and it goes down, sorry. Right? The other one starts at +9 and it goes down the same. What does that mean? These two are parallel. So if they're parallel, are they ever going to intersect? No. So there's no solution. So that's another way to kind of visualize this, right? This is why I tell you my favorite equation of all time is y equals mx plus b, because when I solve systems of equations and they give me a nice one like this, where the y is by itself and I don't have to divide anything to it, I just have to move stuff around, I can visually graph this really quick and see, oh yeah, they're going to intersect. And I can get rid of two answers right away, right? It's either all solution, no solution, or there's exactly one, okay? Plus, I can kind of eyeball it where they're going to intersect, okay? All right, moving on. There's your little mini lesson right there. Okay, if you got it, great. All right, Luis and Madison compare their monthly phone plans. Luis plans cost at $30 plus an additional 5 cents per text. Oh, do you see what I'm getting with this? This is already going to be another y equals mx plus b, right? Because as soon as I see rate, I think about that. So that's one. And then Madison is going to start 15 plus an additional 10 cents per text. So I'm going to write two equations just really quick. So for Luis, I guess it was green, so I'll do it in green. So for Luis, it was $30 plus 5 cents, not 50, that's 0.5 cents per text. So that's T instead of X, same thing. And then for Madison, I got Y equals $15 plus 10 cents per text. So if I just look at this, think about how we're reading this. For Luis, you pay off more at the beginning, right? This is where you start. They started at 30, but it's less per text. Whereas Madison will start off lower, but pays more per text. Either way, these will intersect somewhere, okay? So what do they want us to know? Madison will always pay more every month compared to Luis. Is that true? Well, let me think about it. And I'm going to do this really quick. So let's see. Luis is green, right? So Luis starts at 30. And the slope is 0.05, right? And then you'll see why I did it this way. This is why I love this equation. And then Madison starts at 15. So let's just say it's right here. But the slope is 0.10. And 10 is bigger than 5, which means it's steeper. So I'm going to say like this. So there's your m equals 0.10. Okay. So now let's look at the first question. All right. Madison will always pay more. No, because remember, it's mx, or this is text. At some point, they will cross, right? They will meet the same. But before then, Madison, right here, is paying less money. All right? So that is false. They will both pay the same if they each send 300 texts. So is that my answer where they intersect? How do I solve that? Oh, I just used up the space, it looks like. Well, let's do it right here. This one's really nice. Actually, let me go ahead and do this. Boom, right there. Let me get it a little bit bigger, just for future reference. Okay, so what can I do now? I can set these two equal to each other. So 30 plus 0.05t equals 15 plus 0.10t. And why can I do this in this system? Because the y's are the same. So how do I get these two to be the same? Well, this one has to be the same as that one. Okay, so let's just solve the equation. That's all it is, just solve an equation for t. So 2 steps, right? Add, subtract, divide. So actually 3 steps here, because I'm going to get rid of the t's first. So I'm going to subtract 0.10t. So these go away and subtract 0.10t. So 30 stayed the same. Now let's go to my calculator. 0.05 minus 0.10. That's going to give me negative 0.05t. and that equals 15 on the other side. So how do I get, and again, I'm solving for text, right? How do I get the t by itself? Let's get rid of the 30. So subtract 30, subtract 30. Those go away, and I'm left with negative 0.05t equals 15 minus 30 is negative 15. Okay, not a big deal. Then divide both sides by negative 0.05, negative 0.05. So we got negative 15 divided by negative 0.05. And I get t is equal to 300. So at 300 text, right, your y is the same. And my y in this case, when I graphed it, if this is text, my y is money. All right. So will they both pay the same? Yes. Then it says, let's see, number 3, you can't tell which option is more expensive until you know the number of texts sent by each person. Yes. So right here, they pay the same, 300 texts. Okay. But before and after, it depends, right? So after 300, right, what's going to happen? Who's going to pay more? It looks like Madison's going to pay more. All right. The graph of the functions will never intersect. No, that's false. They do intersect. Okay. All right. So, and if you're like, how do I know which one is more? So think about it. From here to here, right, this one is more. From here to here, that one pays more. From here to here, that one paid more. So from there to there, the green one paid more than the purple one because it's higher on the Y, right? There's more money there. All right, moving back. Rando and Sally have scared a total of, Monsters Inc. All right. So have scared a total of 60 kids today. Sully has scared 12 more kids than Randall. Enter the amount of kids Sully has scared today. Ugh. So here's the thing. Here's my equation. This is like a system right here. I got Randall and Sully. So Randall and Sully have scared a total of 60 kids. What's my second equation? Sully has scared 12 more kids than Randall. So how would I write that? Sully has scared 12 more, and that equals Randall. Okay? So these are the ones that are tricky for us. So let me kind of just think back a little bit. All right, so in this case, I got, so let's see, because I always get these confused, all right? So Sully has 12 more kids. So let's say Sully scares 15. If I do plus 12, that means Randall equals 27. But Sully scared 12 more. See, it's not S plus 12. And that's how a lot of us would have written it, just like I did. So in this case, it has to go on the other side. So Sully scared 12, so has scared. So scared a total, so scared is equal. So S equals 12 more than Randall. And that makes more sense. So let me try this out. So let's see. If I just, again, I'm eyeballing it here. If Sully scares 20, so Randall has to scare, what is that, 8, right? Because 8 plus 12. So Sully scared more. Yep, that's it. Okay. Whew. I just had to make sure. Now I'm happy with it. Let's go ahead and put these together. So there's my system of equations, technically. And this one, I'm going to say, hey, look, that S and that S is by itself. So they are exactly the same. So what I'm going to do is I'm going to use substitution. So I'm going to plug in all of this into that S. So in other words, R plus my S, which is actually Randall plus 12, is equal to 60. Okay, so now that I have that, I can say R plus 12 equals 60. Or in other words, 2r plus 12 equals 60. So subtract 12, subtract 12. Let me double check. 60 minus 12 equals 48. So 2r equals 48 divided by 2, divided by 2. And I got r equals 24. Is that what I want? To enter the total number of Sully. So if r equals 24, how much is Sully? So I'm going to go ahead and use this equation. So 24 plus Sully equals 60. So minus 24, minus 24. And then I can see that 60 minus 24 is 36. So Sully is 36. Now, does that make sense? Sully scared 12 more kids. So if I look at it, 24 plus 12 equals 36. Yes, that is true. Okay. All right. So look at the graph, enter the equation of a line. All right. Pretty chill, hopefully by now. So I have, oh wait, why does it keep going? 8th grade. You guys are using scientific. There you go. Okay. So let's see. They gave me 2 lattice points. Well, that's annoying. Okay, and I'll show you why in a little bit. I know that my B is 1. So that's 1. So that's plus 1. I need to find my M. And then for my M, I've told you before, I find the closest lattice point. So I'm going to use that one. You could have used that one. Or you could have used that one. They told us to use that big red one. So here's the big red one. It's 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my slope would have been 12 over 3. But that is wrong. Actually, that works out pretty nice, okay, for this one. So I take it back a little bit. Just a little bit. The reason I say that is because if it's a fraction, they always want you to simplify. If I use the purple one, the closest points, it's 1 and 4, so my M is 4 divided by 1, which is 4. The reason I said it kind of didn't matter because 12 divided by 3 is 4, is the same. Okay, so then my equation is y equals 4x plus 1. The thing, just a heads up, if I would have gotten 6/8, no, you have to change that to 3 over 4, right? So just kind of think about that, right? All right. Choose all order pairs that are on the line. Okay, here's my strategy. I love this question. It's a little annoying for you guys, but the calculator makes my life so much easy because they basically gave me all the answers. This is an x and that's a y. Because remember, x comma y, that's a point. So what I'm going to do is I'm going to type in my function. So I got 3/4, my parentheses for my x plus 10. So I'm going to plug in, so that's my input and that's my output, right? So if I plug in negative 12 where my x is, so there's minus 12, did I get 1? Yes. So that one worked out. If I plug in 8, and look, I just got to press delete, delete, change it to an 8, I got 16. Check. Delete the 8. Now I'm going to plug in negative 8, and that gave me positive 4, so it's not negative 4. So press delete, and then I put in 16. So if I plug in 16, it gave me 22, so that one is correct. That's it. That's how simple it is when you get to use your calculator, okay? All I had to do was plug in the numbers, all right? Okay, next one, find another point. Let's see, look at the graph. Find another point you can add that will make the pattern a linear. Enter the x coordinate. On the first box, enter the y coordinate, because remember, our point is x comma y. So if I look at this, it looks like I went 1 and 2. So 1 and 2, 1 and 2, 1 and 2. So I technically have 2 answers here, right? I could have said this point right here, which is technically 2 comma 6. Or I could have said that point right there, which was 3 comma 8. So I'm going to use the green one just because It's first. So my x was 2 and 6. Or you could have said 3 and 8. Either one of those would have been correct. Okay. All right, next one. Almost there. Okay, we're on 28 out of 34 here. Daniel uses the equation x squared plus 36 equals 100 to find the missing side of a right triangle. Okay, a squared plus b squared equals c squared. I could see it. What's true about the triangle? The shortest side is x. The hypotenuse is 100. The hypotenuse is 10. So if they told me that the hypotenuse is two numbers, it's probably one correct. So that's a 50-50, right? Like one of those has to be correct. So the thing about a triangle, a right triangle, okay, is that this is A, that's B, and that's C. It's going to be A squared plus B squared equals C squared. So if they told me my A was X, my B squared is 36. B squared is 36. So that's not B. So if they told me that B squared equals 36, I take the square root, take the square root. B is actually 6, right? Because 6 times 6 is 36. And C squared, which is C times C, gives me 100. So C is actually 10. So therefore, my hypotenuse is 10. It is not 100. So the only question is, the short side is X. Well, I don't know. How do I figure that out? I just got to solve it, right? And I kind of already started here. I got x squared plus 36 equals 100, because that's what my original was. So let's solve for x. I'm going to subtract 36. Then I'm left with x squared equals, I don't know, 100 minus 36 is 64. So think about it. X times x is 64. What number times itself is 64? That should be 8. And in fact, it is, because the square root makes that square go away to 1. And I get square root of 64, which is in fact 8. So x equals 8. Is that the shortest side? No. The shortest side was 6. Okay. All right. Moving on. So look at the two shapes below, not drawn to scale. I'm going to take my water break real quick. All right. So it's not drawn to scale. All right. So they're not perfect. That means if this was 5, that looks like 5 too, but they said it's 10. That's all they're saying. Okay. If that was actually 10, it should have been drawn like a lot bigger. Okay. So not drawn to scale. So you got it wrong. Okay, so let's see. What are we doing? Jose claims that the cone is 2 times larger than the sphere. Is Jose correct? Why or why not? So we got to play teacher. Jose's correct. Jose's wrong. Jose's wrong. Jose's wrong. So I see a lot of Jose is wrong here. Okay, so let's see. Let's just do the math then. Okay, so the volume of a sphere is 4/3 pi r cubed, or 4/3 times pi times r cubed, which is 5 cubed. Okay, so let's do that. I got 4/3 times pi times 5 to the power of 3. And that gives me 523.5987756. Okay. What about the cone? The cone, can I fit it in there somewhere? Do I have space down here? Kind of. I guess I'll do it right here. Okay. So the volume of the cone is 1/3 pi r squared, h. So I got 1/3 times pi. My r is 10, so I square that, and my h is 15. So put that all in the calculator. So 1/3 times pi times 10 squared times 15. And that is roughly 1570.796327. Okay, so what did Jose claim? Jose claimed that it is 2 times larger. So what's the comparison? I got 523 times 2. Is that 1500? No, it is not. So I know Jose is wrong. It is not 2 times larger. Can I do the math and then divide those two? Okay, so 1570 divided by 523. It looks like it's not 2 times larger. It looks like it's 3.00192.046. And I'm pretty sure it's going to be 3 times larger. If I used all the decimal, and I've talked about it, right? The more decimal places you use, the more accurate it is. Just to prove it to you, 1570.796327 divided by 523.5987756. Boom, right there. It is exactly 3. Okay? And if you notice, the more I added, look, the more accurate it started being, right? So instead of saying 4, then 3 and 2, it just ended up being 3. Anyways, let's move on. The cone is actually 3 times as big because the height is 3 times as big as the sphere. Oh, damn. The height is 3 times as big as the sphere. Well, how big is the sphere? The sphere is actually from here to here, right? But if this is 5, the other one should be 5, so it's actually 10. So is that 15? No, that's 10 times 3. So that's not it. Okay, it's not 3 times. Jose is wrong because 4. So let's see. 4/3 times 5q equals 3. So essentially, these are just the equations. Did they do anything? No. These just means that they are equal. Okay, that is wrong. They are not the same. This was weird, the way they worded it. So now I'm going to double check, right? 4/3 pi 5 cubed. 4/3 pi 5 cubed. The other one is 1/3 pi. So what are they missing? I got 10 squared and 15 and pi. This one is missing the 1/3. Oh, I screwed up. See, that's, oh, I gotta like triple check this. This one right here okay. Wow, the way they worded this sucks. Okay. So I just want to show it to you, okay? 4/3 pi 5 cubed equals 1/3 pi r squared times h. These are exactly the same formulas. Right here tells you that they are the same, okay? We already said they are not the same. What did we learn? We learned that the cone is 3 times bigger. So that means that the sphere stayed the same. 4/3 pi times 5 cubed, right? And it stayed the same. That's the same. That's the same. But on the other side, I multiplied this whole thing by 3. So if I multiply 3 times 1/3 times pi times 10 squared times 15, 3 times 1/3 gives me 1 pi. So I'm left with pi times 10 squared times 15, which in this case happens to be right there. Wow. So the answer is actually D. Okay, that was crazy. So that's a really advanced level kind of questions, at least to me it looks like, because the other ones have been pretty straightforward, I think, compared to this one. So we had to think about this one a little bit, right? And I had a double, triple, quadruple check, okay? It was multiple choice. At least I narrowed it down to 3 options, all right? But even then, can you tell out of those 3 options, these two look identical-ish? And usually on a multiple choice, if they look pretty much the same, it's it's one or the other. Okay, we just had to read it correctly. Okay, yikes. Okay, number 30. All right, last ones. The local hobby store is jumping on the Pokemon card craze. Oh my god, the stupid Pokemon cards. Okay. All right. By the way, when I was your age, that's when they came out. I remember going to buy one. Okay. I didn't know how to play with that thing, so I think I bought one pack and never cared again. Okay. Anyways, moving on, since they're making a comeback. They have enough space, so looking at, what was the store again? Okay, a hobby store is jumping on the card craze and decides to make room on their shelves for the cards. Okay, that makes sense. They have enough space to hold 2 to the 8th packs of cards. Each box holds 2 to the 3rd packs of cards. How many boxes should fill into the shelves? Okay, let me see a visual here. So I got my shelves. Okay, there's my shelves. And I got a bunch of boxes. So in the shelves, it says that they got 2 to the 8th, whereas my box has 2 to the 3rd. So in other words, how many boxes fit into the shelves? Okay, so that's just division, right? So let's see. I'm going to take 2 to the 8th divided by 2 to the 3rd. So 2 to the 8th. Nope, that's not how it looks. So fraction button. 2 to the 8th over 2 to the 3rd. And I get 32. Yeah, that was it. That was pretty simple. How many boxes? There are 32 boxes that fit into there. Okay. All right. Yeah, that should make sense. Okay. All right. So let's see. Last, 4? Yes, last 4. So Liam solves the following equation for x. His work is shown below. He concludes that x equals 3 is the only solution. Is he correct? Okay. So it doesn't say that he is. Anytime we're doing this, let's just solve it ourselves and figure out if it's true or not. Okay. All right. Actually, if I'm looking at the answers, it has nothing to do with that. So I think Liam did everything correct. It's just the interpretation. So let's see what I'm talking about. Is there space here? Damn, there's no space. How am I supposed to do this? All right. So I'm going to try to make my space right here. Damn, that's going to be tiny. Okay. So I got x. And then I got 6 times a half. That's half of 6, which is 3. Plus 2x equals, and then distribute. And I get 3x plus 3. Okay, that's not horrible. So there's my little wall right there. Okay, I got x's with x's, units and units. Remember, I can't go across yet. So on the left side, I got 3x plus 3. On the right side, I got 3x plus 3. So they're exactly the same. So if I subtract 3x, those go away. So 3 equals 3. So yeah, that is totally what I got as well. So he says that x equals 3. I know that it is wrong. So he is not correct. And look, incorrect, incorrect, incorrect. So I got 3 options. Because x equals 0. No, there's no x. X is gone. So there's only 2 options. No solutions or all solutions. And because 3 equals 3 is true, this is all solutions. Okay. Now remember my favorite equation of all time. Just a hint, hint. Y equals mx plus b. Y equals mx plus b. So if they cross, that's one solution. If they never cross, that's no solution. Right? That means they are parallel. We talked about it earlier. And when do you get all solutions? When they are exactly the same. So if this is mx plus b, it's 3x plus 3. The other one is 3x plus 3. So they're exactly the same equation. So if they're exactly the same equation, they're always going to be stacked on top of each other, which means it is all solutions. Hint, hint, okay, that's another way. But it only works when you see mx plus b, then you can compare, okay? All right, moving on. The table below shows a linear function. Enter the rate of change. Okay, so in other words, that's your m. Okay, so my equation is y equals mx plus b. Or I could figure out what did I do to get 15. A lot of you are like, times 5. Yeah, that doesn't work for 6. Okay, so that doesn't work. Okay, so let me try 6. 6 times 4, that gives me 24 plus 3 equals 27. 3 times 4 equals 12. 12 plus 3 equals 15. 13 times 4, I don't know what the heck that is. 13 times 4 equals 52. Then I add 3, that equals 55. So notice my strategy here is I said, what did I do with the x? I multiplied times 4. So do you see that? That is your m. So that's 4x. What did I do after? I added my b. My b, what did I add? I added 3. So what is the rate of change? My rate of change is just 4. That's it. Is that easy? Okay. Now, is there another way to do this? Yes. I'll show you an easy way. Your rate of change is m. If you remember your equation, is change in y over change in x. A fancy way of saying y2 minus y1 over x2 minus x1. Well, what can I do here? How did I get from here to here? I added 3. How did I get from here to here? I added 12. What did I do with my y's? I subtracted. What's 27 minus 15? 12. What is 6 minus 3? 3. What's 12 divided by 3? 4. So again, find the difference. That's what delta means. The change in y and the change in x. And then divide them. And then you're done. Okay? All right. Which one of these is a function? So let's see. When you have a graph, you do the vertical line test. So one of the ways to know it's a function, basically every input, aka your x, has only one output. In other words, x's can't repeat. So on a graph vertical line test, look, if my x is 5, I got an output of whatever that is. I got 2 outputs. No. So my x's, I got 6, 8, 3, oh, I got 8 and 8. My output was 6 and my output was 6. Oh, wait, they are the same. So this one is a trick question. That means that one's okay because it's the same point. Okay. This one I got 3, 1, 8, 9. They're all different. That one's good. And this one is just a line. If I were to graph this, it just start at 5 over 7. And it'd be a straight line. And yeah, it's vertical line test, right? You only get, it only crosses one time. It doesn't matter. All right, so that's it. Oh no, one more. Okay, last one. Whew. Okay, a family ordered 10 meals at a restaurant for a total cost of $139 for 10 meals. Actually, is that bad? Like that's like $14 a meal. Okay, I mean it's not great. It's not horrible. All right, they also ordered 4 desserts and 5 drinks. Ooh. All right. So adult meals cost $14 each. Desserts cost $8 each. Drinks cost $3 each. Child meals cost $8 each. Enter how many adult meals were ordered. So this is a system of equation thing, okay? So I got to be careful because I got a total, that's my total, right? 10 meals. So that means your adults plus your child equals 10 meals. But here's the kicker. You also ordered 4 desserts and 5 drinks. Now where it gets different is now you're talking about money. And all of these have money prices attached to it, right? So these are one equation on their own, okay? Whereas A plus C had to do with adult meal, child meal for 10 meals, okay? Now the other one is going to be, okay, adult meals, I had 14 each. Notice that's my rate. So I had 14 per adult. You see that? Like $2 per hot dog, $10 per game. Okay, so $14 per adult meal. Then I had child meals, $8 each. So that's 8 per child. Now here's the kicker. I ordered desserts and they told me it was 4 desserts at $8 each. So if I say 4 desserts, 4 times 8, that's $32 for desserts. Then drinks. I had 5 drinks. Each one is $3, so that's 15. And again, everything is money, right? $15. What was my total? 139. Ugh. Okay, that looks gross. So 139. Okay, so it's just a system of equations. I got 2 equations with A and C on both. Let me simplify the red one. So 14A plus 8C, and I got 32 plus 15. 32 plus 15 is 47 equals 139. So I'm going to subtract 47, subtract 47. Those go away. I got 14A plus 8C equals 139 minus 47, and that gives me 92. So notice my 2 equations. Can you see that it's a system, right? The A's are stacked on top of the A's, the C's, and then the units on the other side. So if I go back to this, it's just another system. I got A plus C equals 10. I got 14A plus 8C equals 92. So what do we want to solve for? We want to solve for adults. So we want to get rid of the C. So I'm going to multiply the top times negative 8. Can you see why? Because I have a positive 8. So if I distribute it to everything, that's going to give me negative 8A minus 8C equals negative 80. For my other one, nothing happened. So 14A plus 8C equals 92. So now what happens to the C's? The C's are gone. I'm left with 14 minus 8, so that's 6A, equaling, what is that, 92 minus 80, 12. So divide by 6, I had 2 adult meals. Not $2, right, because A was the adult meals. So I had 2 adult meals, and it was a total of 8 child. Okay. So that's pretty crazy. If I put that in my calculator just to make sure, this one right here, I had $14 times 2, right? Because it's 2 adults, plus I had $8 per child. But in this case, if there's 2 adults, so there's 8 children. Plus 40, plus 32, plus 15. And guess what? That equals $139. So there we go. 2 adults. Okay, that was a lot of kids in that meal right there. Okay, so that was it. That was your recap of a bunch of stuff, okay? So like I said, take this as like your practice exam. I knew it was long. You had some mini lessons in there, but hopefully you picked up some of the strategies I shared with you, and you take advantage of it. All right. So good luck. Until next time.